Hello everyone, welcome back. Today's topic is system memory, that is RAM, RAM. So what is RAM? RAM is also known as random access memory. It is your computer's short-term memory where it stores data that's actively being used for quick access. It is fast and temporary. RAM is much faster than a hard drive or SSD, but it only holds data while the computer is on. So the moment you turn off your computer, the data are gone. Number two, it helps multitasking. More RAM lets you run multiple apps smoothly without slowing down. It is also volatile in storage. Unlike a hard drive, RAM loses all data when the power is turned off. It's measured in GB. Typical computers have 8 to 32 GB of RAM, that is gigabyte. More is better for gaming or heavy tasks. It works with the CPU. It feeds data to the processor quickly so program can run faster. Types of RAM: DDR4 and DDR5, etc. Newer RAM is faster and more efficient. It is also upgradable. Many PCs let you add more RAM for better performance. In short, RAM is like a workspace for your computer. The better it is, the more you can do at once. Now, we will learn about system RAM and virtual memory. System memory. A system memory is the computer working storage RAM, where active programs and data are kept for a quick access by the CPU. Memory controller. A chip that manages data flow between the CPU and RAM, ensuring efficient memory operations. Volatile RAM. Volatile RAM is a temporary memory that loses all stored data when the power is turned off, like a regular RAM. Now, what is virtual memory? A system that uses part of the hard drive as extra RAM when physical memory runs low. Page file swap space. The reserved area on a storage drive used by virtual RAM to extend available RAM. Protected mode. It is a CPU operating mode that prevents programs from crashing the system by restricting direct hardware access. Now, let's understand this diagram. The image compares 32-bit and 64-bit CPU architecture. It is the 32-bit, and this is the 62-bit CPU. It highlights key differences in memory handling. First, we will learn about the 32-bit CPU. Chooses 32-bit address bus, limiting RAM access to 4 GB of virtual memory. Data travels over 64-bit data bus faster than the address bus. Paging storage like virtual memories relies on slower mass storage HDD and SSD. Now, 64-bit CPU. It uses 48-bit address bus supporting up to 256 TB of virtual memory. Also has 64-bit data bus for efficient data transfer. It handles vastly more RAM and virtual memory, improving performance for modern apps. In short, 64-bit CPU outperform 32-bit ones by supporting more memory and faster data processing. Now, we'll learn about memory modules. So memory module in a RAM is a physical component that holds your computer temporary memory, that is RAM. Here are the simple breakdown. The one is small circuit board. It's a stick-like module like DDR4 or DDR5 that plugs into the motherboard. It also stores the active data. It holds programs and files currently in use for a quick CPU access. Volatile memory. It loses all data when power is off, unlike storage devices. It is measured in GB. Common size are 4 GB, 8 GB, 16 GB, etc. More RAM is equal to better multitasking. There are several types like DIMM for desktop, smaller SODIM for laptops. Faster module, for example, 3200 MHz can improve the performance also. It's easy to upgrade, so you can add more modules to boost your PC's speed. So now we will understand about the dual inline memory module DIMMS. It is a memory sticks used in desktop or servers with separate pins on each side for faster data transfer. Each generation, DDR3 or DDR4, has unique speed, voltage, and physical design. It is not interchangeable. Flat keying. It notches on RAM modules, prevent wrong insertion into compatible motherboard slots. Module speed and motherboard speed. RAM speed, for example, 3200 MHz, must match the motherboard support to avoid bottlenecks or underperformance. Small light line DIMM, SODIMM. It is a compact RAM sticks for laptops, small PCs, same function as DIMM, but half the size. So basically the SODIMM is smaller in size. Now we will get to know about the ECC RAM. So ECC RAM, also known as the error correcting code RAM, is a special type of memory that detects and fixes common data errors automatically. It finds and fixes errors, like identifies small mistake, like flipped bits, and correct them in real time. It is more reliable, used in servers, workstations, where crashes or data corruption can't be risked. It is slower and costlier, slightly slower than other RAMs, and more expensive due to extra tech. It is not for gaming. Most PCs and gaming rigs don't need it, ideal for critical systems like banks or hospitals. It has extra chip, has an additional memory chip for error checking unlike standard RAM. Now, error coding code, ECC. It adds an 8-bit checksum data transfer to spot the errors, fixes 1-bit errors, and detects larger errors like 2, 3, 4 bits for extra reliability. Registered DIMM, RDIMM versus unbuffered DIMM, UDIMM. RDIMM uses a buffer to stabilize signals better for servers, while UDIMMs are simpler for desktop only. Now we learn about the processor CPUs. CPU, which is also known as Central Processing Unit, is the brain of your computer that does all the thinking and calculating. Here is what it does in simple terms. It executes the instruction, it runs program and process by following step-by-step command. The speed is measured in GHz, that is gigahertz. A higher numbers mean faster performance. Cores, like multiple mini brains, example dual core and quad core and many cores is equal to better multitasking. Cache memory, super fast inbuilt memory to store frequently used data for quick access. It works with RAM, which pulls data from memory to process tasks quickly. Generations. There are new generations in the newer CPUs like Intel Core i9, AMD, etc. are faster and more efficient. It heat and cool. CPU get hot and need fans or liquid cooling to avoid overheating. In short, your CPU does all the hard work to make your computer run smoothly. So we learned about the CPU architecture. CPU pipeline. It breaks tasks into stages like fetch, decode, execute, or write back to process instruction faster like an assembly line. CPU grabs an instruction that fetch, understand it, means decode, perform that task like execute, then save the result right back. Registers and cache. Registers is a tiny, super fast storage inside the CPU, while cache is slightly larger quick access memory for frequent data. x86 CPU architecture. It is a classic 32-bit design used in most older PC, known for storage compatibility but less efficient than newer design. 32-bit IBM PC compatible instruction set. It is the standard command and operation used by early PCs, now mostly replaced by 64-bit systems. x64 CPU architecture. The modern 64-bit upgrade to x86 now more memory and better performance for today's software. Advanced RISC machine, CPU architecture, a streamlined power-efficient design used in phones and tablets, focusing on doing more with less energy. System on a chip. System on a chip packs CPU, GPU, memory, and other components into the chip. Common in smartphones for compact efficiency, better power and thermal efficiency. Modern CPUs like ARM and x64 uses less energy and produce less heat, ideal for laptops and mobile devices. Software compatibility and emulation. The older software may need emulation to learn on new CPUs as architecture evolves and changes over time.